Welcome back. This video is a continuation of the previous video on data exploration. In this video, we will look at split, apply, combine, which is a technique to summarize data very effectively and efficiently and draw insights based upon data summaries. For those of us used to Excel spreadsheets, we know of this as pivot tables. And I will lead with a very simple example. Imagine you have a large single data set that contains records of all of your customers across all of the states in the United States. And it also has a column for their income as well as for their gender. What you want to do is you want to know for each state, you want to know the average income for your customers. So you take the entire data set and you split it by state first. Then you apply a function, in this case the average or mean as a function, to each of those splits that you have created. And the resulting answers that you get, you combine them together into a single set that gives you all the information in one place for all of your customers. So for every state, you know what their incomes are by state. While you are at it, you might like to say, hey, not only do I want to see the averages by state, I also want to see along the top, I want to be able to split it by gender. And you can do that quite easily using pivot tables or the split, apply, combine methodology. With this, let's switch to the slides. And there you go. The phrase split, apply, combine, this was actually made popular by Hadley Wickham, who is an extremely smart individual. He's the author of the popular dplyr package in R and also many others, ggplot, for example. Conceptually, the idea behind split, apply, combine is exactly how I explained it, which means you take your entire data set and you split it into subgroups based upon some filtering criteria. In the example that we looked at, we split it based upon state. Then you apply a function to each of the subgroups you have created. And in this case, we applied the function mean in our hypothetical example. And then finally, we combine all of the results into one single table. And that is what split, apply, combine means. Now, split, apply, combine does not represent three separate or distinct steps in data analysis, but this is really a way of thinking about how to solve a problem by breaking it up into smaller chunks and operating on each piece separately, and then put all the pieces back together. The split, apply, combine operations. These are implemented using many different functions in statistical packages, and you'll hear names such as pivots, pivot table, crosstab, group by, melt, stack, and so many others. And those are all variations along the split, apply, combine concept. The most common implementation of split, apply, combine is through pivot tables. Pivot tables were popularized by Excel, and in fact, uh, Excel is credited with coming up with the idea behind split, apply, combine. They're used by most Excel power users, and in your company or wherever you are working, you definitely would have come across pivot tables. Let's look at an example to understand how pivot tables are organized and how they work. So pivot tables, they have three main elements. So those who have seen a pivot table, and if you haven't, we will get to those in a minute, so bear with me. They have three main elements. They look like a table. On the left hand side, they have what is called an index. Across the top, they have columns, and in the middle section of the table, they have values or numbers. And these numbers, they can be averages, they can be medians, standard deviations, they can be just about any function that you can think of applying to the intersection of whatever is in your index and whatever you have picked for your columns. Now, this can get very conceptual, so let's dive straight into an example. Let's consider a random data set. Now, this is a completely random data set. created using random number generation. And as you can see, it has several fields. It contains for different individuals, it has a state, the gender, education, their housing situation, height, weight, what their income is, the number of computers in their home, etc. And what we want to do is we want to be able to see what the average income is for each of uh, the two genders, female and male, and we want it split by their education level. And we can do that quite easily by creating a pivot table that looks like this. And you can see this is a really nice summary. I can actually see that high school graduates who are women, they have an average income of 147.5, whatever that number is, and so on. So let's just go deeper into what this is and how this is set up. Now, for those who are going to be looking at the code videos, you will see that the code appears here. And those who are not going to look at the code video, they can ignore this information. On the left is our index column. The index column has two distinct values, female and male, and those appear at the bottom. Across the top are the columns. So we had picked education as our column. And then to the right of that are the unique values for that particular column. So these are the three different distinct values that appear under education in my data. Now my data for this particular example had 2,500 lines, and it had no difficulty summarizing them in a very simple, easy to understand table here. The values that appear in the middle of my pivot table, that's the value column, and that is income, and those appear here. And what kind of income statistic appears here? In this case, we selected mean, but we could have well selected minimum, maximum. We could have selected the median, the 25th percentile, or just about anything that we can think of. This is a simple pivot table, but it is possible to make it arbitrarily complex as well. And we see another example of that in the next slide. So here, for example, we have a much larger pivot table, again, based upon the same data, and which is, trust me, it's completely random data. There is no science behind it. It was generated using a random algorithm. And those who will be looking at the code videos will see how that particular data set was generated. Anyway, that said, on this data set, here again on the left, I have my index columns. I have my columns here uh, for the uh, for going across the columns. And then here are the values. And you will see that the two value columns that I selected, computers and gender, they have different aggregation functions that we have used to summarize the data. So for computers, we wanted to see both the mean and the median here. And for gender, we wanted to see just the length, which basically means the count of how many of these observations are there in our data. Now, gender is a categorical variable, so obviously you cannot calculate the mean or the median or any of those other numerical quantities, but you can count the length of how long, how many records are there. So that is what this represents. And again, for every value in the education field, we have the split between owners and renters, same thing here, and so on. What this means is that when we create pivot tables, we have to think carefully about what we choose to show along our index columns and what we want to show along our columns which go across on the top. If we pick a variable which is not categorical or has too many unique values, this list, either on the top or on the left, is going to be extremely large. So that is one thing to bear in mind. The second thing to know is that what you pick here for the values, it is most efficient to pick something which is numerical so you can do some operations on that and calculate some summary statistics. So that is always very helpful. But again, there is no limitation to what you can do with pivot tables, and the best way to learn them is to try them out. If you're a manager or a leader and you have a team that can create pivot tables for you, you can actually point them to the columns that you would like to see on the left and those on the top, and they can build these things for you. And you can also tell them whether you want to see the mean, you want to see the median, you want to see something else in your value calculations. And all of these are possible in just about every statistical software. What you see on screen was generated in Python, but let me also show you how the same thing can be done in Excel as well. In fact, Excel's pivot table functionality is very similar to this. Let's look at that now. There is an Excel spreadsheet with data from our diamonds dataset. Again, very familiar to us. And what we want to do is look at how we can create a pivot table on this data. Maybe what we want to see is we want to see what is the average price by cut and clarity for our data set. So we go to Insert Pivot Table and click OK on the defaults, and we get exactly the same things that we just talked about. So there are four elements here, and let me point them out on screen. You can ignore filters for the moment because really this is like a top level thing where you can subset your data or take a portion of your data before you apply a pivot table to it. The only things that are relevant to the pivot table are the three things we talked about: columns across the top, rows to the left, and remember, we called these index when we were looking at the slides, but that's the same thing. This is the same thing as index. Excel calls it rows, and those are called indexes in Python. And values, here we look at the columns that we want to see the values for, and it is also possible to specify right here the aggregation function to use, whether we want to use counts, standard deviations, or whatever else we want to do. So for example, if we were to put cut here, we will see all the items appear here. And if we were to put, say, color here, then we see all of the colors appear. And then we can just pick about any column and we can put it here, and it shows us, it's going to show the count of clarity, how many items of each are there. And we can change the summarization function here. We can use average, we can use sum, we can use minimum, maximum, product, and the list keeps going. Anyway, enough said. So we are back on the slides. Let's look at a couple other things. Wide versus long data. And you will hear these terms. Sometimes our data is really wide. Like there are so many columns. You can actually flip them around and bring the columns to align on the rows. Of course, it will increase the count of your rows, but you can bring them all in together. And this is a simple example of wide versus long data. So in this small and simple hypothetical example, it doesn't help us much. But if we had lots of columns to the right, it would have been we could have made it a 3-column data set where the column names, they appear as a value here against every line item that we have, and we can get the value right next to it. So this is something to know about. Your data science team or analytical team would be able to do this for you if you have a lot of data. And if you're going to practice this yourself, then this is also explained in the code videos for this course. The next thing is crosstab. Crosstabs are really just counts at the intersection of two different columns. So you can create a crosstab very easily in Excel. You would do it using pivot tables, but in Python and other places, there are separate functions that allow you to do that very quickly on extremely large data sets. And here is an example of a crosstab between color and cut from our diamonds dataset. One final thing I wanted to mention was that there is software and there is libraries available that do a lot of this analysis for you automatically. What you see on screen is an example of one such report that you can generate very easily in Python to analyze your data. What you get is a report in HTML format that you can share with your manager, with your client, or whoever else you'd like to. And it gives you a lot of information on the statistics and other information around your data. So what you see here, for example, is for caret as a variable, it will tell you that there are no missing values. It will give you a distribution here, which means you can see that most of your caretage is concentrated in the 0 to 1 range and so on. And for uh, categorical variables, it will tell you how many distinct values are there. So there are 5 distinct values of cut, and they are here, and it gives you a nice bar chart as well. And all of this analysis can be done within a matter of seconds, and it is possible for you to ask your team to do it for you. And if you're going to be looking at the code videos, we will cover this as well. Here is the same report in being viewed in the browser. This is the report that was created automatically. And again, this is what I was showing you in the slides, but it's slightly better to see on screen like this. You can see a lot of the information on color. There are 7 distinct values. For example, you can click on more details and it is very nice. It gives you a sample of the data as well. You can click on categories and you can see how many uh, and counts and percentages are available. It gives you some nice graphics as well. So many of these things have already been automated away. So you don't always have to do it yourself. You can ask your team, or you can just run a very quick Python command and apply this to any data set that you might have. And with this, uh, we end our videos on data exploration. Hope you enjoyed it and this was useful to you. Next, we are going to cover data visualization. Visualization is a key part of exploring data, as we will see, because it can help you uncover patterns that may otherwise not be visible through descriptive statistics or the kinds of techniques that we have seen thus far. So see you then in the next video on data visualization. Thank you for joining.